Hi everybody, I wanted to go over Module 4 of Exponents. It will come up in some other things we're working on, but you need to know it, and you definitely need to know it for the final exam. So there are some different rules for exponents. The first one is called the multiplication rule. And notice what I have here. If you have the large number at the bottom is called the base. The little one is called the exponent. So if you have the same bases and you're multiplying them, all you do is add the exponents. For example, c to the fourth times c to the third times c to the second. All we would do is add the exponents, and we get c to the ninth. Now, if there was some number in place of c, we would put it to the ninth power. This one, x to the 12th times x to the 32nd. Think to yourself what we would do. Yep, you would add those exponents and get to the 44th power. Now, if we have coefficients in front, we do something a little bit different. The coefficients up front are still multiplied. Those numbers are multiplied like normal. So I would do -2 times 3 times -5. But when it comes to the exponents, I need to add them. And look what I have here. Over the x, I have a 1. It's understood there's a 1 there. So it's 1 plus 3 plus -2. And then that would come to 30x to the second power. Okay, down to this one, when we have more than one variable, we just need to do the rule for each of those variables and the coefficient. So when I have 2 times -4, I do that at first. Then I combine the x's. Notice I've got 1 here and 2 here. So I get x to the 1 plus 2. The y's, I have 9 and I have 4. So I have 9 plus 4. And then the z, well, all I have is a 3, so I just bring it over. And then I combine them, and I multiply, and I get 8x to the third, y to the 13th, z to the third. It's good to have alphabetical order. Not necessary, but you should try to do that anyway. Okay, now our next rule is called the division rule. It is very, very similar, except when you have the same bases and you divide, you subtract the exponents. So a lot of times you'll have them as over each other. That's division. So if I have 6 to the 14th divided by 6 to the 5th, c that is, I would subtract the exponents, and I get c to the 9th power. Now here I have a to the 6th and a to the 14th. Notice what I do. 5 minus 14. Plug that into your calculator exactly that way, and you get to the -9th power. Now when I have more than one, all I'm going to do is do the rule for A, that's 2 minus 4, do the rule for B, that's 3 minus 7, and then I get A to the -2, B to the -4. Okay, this one could look tricky. -8 and 4. So I have -8 minus 4. If you just plug that into your calculator exactly how you have it, -8 minus 4, you'll get the -12th. Okay, and coefficients, just like in the multiplication, we multiplied them, but we have to actually divide the coefficients. So do 8 divided by 2. That gives you 4. Then I have exponents 1 minus 4, and I get 4x to the -3 power. Okay, the power rule. This one, if you have something to a power, parentheses to a power, all you do is just multiply those powers. So if I have x to the second, y to the second, parentheses to the second, it's sort of like a distribution, I guess you could say, but I would have, let me move this guy over a little, x to the 2 times 2, sorry that dot wouldn't move up some, and then I have y to the 2 times 2, and then you got it, x to the 4, y to the 4. If I have a coefficient, I need to do the coefficient to that power. So I typed it out as 2 times 2 times 2 times 2, but you could say 2 to the 4th power. And then I have x to the 4th power, y to the 4th power, and you see I get 8x 16, 16. Excuse me, x 16, y 16. Okay, now if I got something really big like this, you just have to take it one little step at a time. So, what I did is, I started at the beginning, and I did 3 to the 5th power. I typed it out as 3 times 3 times 3 times 3 times 3. Then I have m to the 2 times 5 power. And I have n to the 7 5 power. Then at the bottom I have m to the 1 power times 5. I just wrote 5 because that's basically what it is. Now if I clean this up a little bit, whoops, sorry about that, I get 243 to the m10 n35 power. But there's one more thing I can do here. Notice these m's. I can divide them out. So I would have 10 minus 5. So my answer actually is going to be 243 m to the 5th power n to the 35th power. Okay, the fraction rule. When you have something in a fraction, you can take away the parentheses and put the exponent to the top and the bottom, just like this. I didn't give you a lot of examples because this is basically what we do. Notice we have x to the 2, y to the 1 power, the whole thing to the 4th. I rewrote it as x to the 2, y to the 4, y to the 4. Then I have to do my multiplication rule, x to the 8th, y to the 4. Now if there was anything else I could simplify, I would just simplify it. The zero exponent rule is so awesome. Anything to the 0 power is 1. Period. So, if I have something, like if I have 2 to the 1 power, 2 to the 0 power, that's 1. 750 to the 0 power, 1. 8,344,744.720 to the 0 power, 1. So, this big old thing right here, that whole thing is equal to 1. Now, if you worked it out, you would have done 4 times 0 is 0. Negative 9 times 0 is 0. And 7 times 0 is 0. 9 times 0 is 0. And you would have gotten 1. This big old thing, you might think, oh, I'm going to have to go through all this division. Nope. The whole thing to the 0 power is 1. So that's a nice one to know. And then our last one is negative exponents. Negative exponents allow you to move things to make them a little bit easier for you. So, if I have something to the negative power, I can just change it to the positive power and move it to the opposite side of the fraction. So, remember, this is actually w to the negative 12 over 1. All I did was just flip the fraction and make it a positive 12. That comes in handy when you have an actual number here. What I would do first is, I would flip it, make it 1 over 3 to the 2nd power. Now I just do 3 times 3 gives me 9, and I've got 1/9. Now, if I have something a little bit different like this, you might say, well, shouldn't I just multiply and get my negative on the inside? You could do that, but watch what I do first. I just flip the fraction and call it a positive 2 power. Now, what I'll do is put the 2 power on the inside from my rule from before. 5 to the 2nd over 2 to the 2nd. And then I'll just multiply them out and I get 25 over 4. And if I could have simplified that, I would simplify it. But it's in simplest form. Thanks. Have a good day.